So without further ado, just a quick blurb on EPON itself. So we're a consulting firm, originally founded in France in the early 2000s, 2002. Eventually settled in the US in 2014. Our US founder is actually here right now, Roman. Since then, we've opened offices as well in DC and New York. But we're still French, so we brought Arnaud here. He is, of course, from France. He's the data practice lead in France. So he has prepared for you a presentation titled Green Data is the New Big Data. And he will explain what that means, because it's his presentation. So without further ado, here's Arnaud.
Thank you, Nick. Hi, everyone. I'm really happy to be here. So I will introduce you with a subject I care for. This is how to optimize that amount, that mountains of data we have to get it greener. And as you will see, it will be only a matter of good practices, common sense, maybe a new approach, a new strategy to think how we approach use cases. Let's go. So, as Nick said, we're a global company. We have 3 offices in the US, 6 in France, 1 in Moscow, 2 in Morocco, and 1 in Australia. And as a global company, we try to work together the most we can. And from that perspective, we are conducting the Data Week in EPON and training new people to Spark or Kafka or state-of-the-art training, and to bring together new people to form a global community. I'm a senior data architect. I work for like 15 years around data-oriented projects. And at the beginning, I was playing a lot with the guys at the bottom, like Hadoop, Spark, and more I'm playing with cloud technologies, and Snowflake and Matillion are my two new technology I use a lot. And as a matter of fact, I now lead the data practice for France. So I help people working together, and I accompany sales to do some business development. Why we wanted to give this talk is because that approach is rather interesting for us, because by marketing to be a green thing, it is also a cost way to save costs. So it's easy as soon as you keep in mind that you have only to think about it. It can become an habit and a good data strategy, and it's rather easy. Why EPON qualifies to talk to you about that kind of technology is that because we're a cloud-first company, and we are AWS Advanced Consulting Partner. And what our particularity is that we have the AWS Data and Analytics competency for 6 months. In the US, there is like many consulting company, but in France, we are only 2 to have this competency. That's it's a differentiator for us. And what also is interesting is that the cloud technologies change the IT landscape. AWS launched EC2 in 2006, and from them it kept evolving to bring more and more new services. As we will see, we are now focused on serverless services to optimize our architectures. So I wanted to use that idiomatic because it's only a matter of common sense sometimes to optimize things. So the first thing to know is you try to keep things at the source and to keep it simple as possible, and not to store and process data you don't need. And that's the best way to keep things optimized, is to do as minimum processing as possible. The storage is rather cheap, and not that energy consuming, but the processing can be a lot energy consuming. So you can optimize it by using the right storage format, like a columnar format. You can also, of course, compress your data. You can use lifecycle policies to decrease the amount your data you store from time to time. And you can also use ideation techniques like design thinking techniques to take your use case from the dashboard and from the visualization to do some business interviews to reduce the amount of data you need to store. And the other principle is frugality, and it's one that is widely employed at Amazon, and it tends to get you focus on using only what you need and not more. And that is a good principle to keep in mind when you design data architectures. A Brief History of Time is a title from of a book from Stephen Hawking. I recommend it to you, and I wanted to browse through different architecture that pattern over time. The first one is the mainframe that you must know very well, but on this one, everything was centralized, so we didn't need to build complex pipeline to centralize data. They were all stored on the same place, so that was rather convenient, but the complexity was growing, so we designed client-server architectures, and that's when we started to silo the different databases. And it was not a problem at the beginning because we didn't need to do some cross computation. But when we began to want to centralize data, we understood that we needed new tool. So we introduced data warehouses to centralize data to be able to do some joins. And then to do that, we needed to use like ETL tools, because data warehouses has fixed schema. So you need to transform to take your data from the source and to transform it to be able to store it. But data warehouses are already mature, but they are rather expensive, and the ETL2 are expensive and they don't scale that well. So when you need to increase the size of a data warehouse and to do some backup, it's rather complicated. So big data come in, and Google released a white paper about Bigtable that became Hadoop, and that enabled us to build some data lakes. So we have an object storage, a raw object storage, where you are not constrained by any schema. You can store data as they come, and then you apply your schema once you consume the data, once you want to process it. So you need processing power to be able to apply schema on a data lake. That's called schema on read, and then to store it in a published publication repository that is often a data warehouse. That approach is really powerful because you can scale almost infinitely. You can scale separately your storage and your compute, and you can fit your business needs in the closest possible way. You are not obliged to add more and more storage as soon as you add compute. You can increase only the needed resource. But it's a bit more complicated, and the technology has more and more advanced, so you need to keep your people upskilled, and we will see that with simple approach we can get things, we can simplify things. Distributed storage is interesting because it will enable you to have replicates of your data, so your backup are enforced in by the software, the underlying software, for example HDFS, But you need to keep in mind that you shouldn't use this as a database. You cannot do update. You shouldn't do update on vast amount of data. You need to copy it and apply changes to the copy. Instead of trying to update a column, it's better to add another column to do your computation. You can also use distributed framework, like for example Spark, to distribute your computation, because what you need to keep in mind is that on data architecture, I/O are the bottleneck. Almost always, the network is the bottleneck, so you will want to distribute your data once, and then to distribute your code often, because code is faster to distribute than data. With that in mind, we will try to see how we can reduce the amount of data we need from the source, from the use case, by using ideation techniques. You first need to know your data first. Everybody is used to schema data with a strong schema like CSV, XML, JSON, but data like email, audio recording, images are a bit more complicated to use. So you need, for that, you need to use machine learning and AI services to get value from that data. And you can also collect more data. If you use, for example, sensors and or other tools, other devices, you can bring in more and more data. And you can also buy data from third parties or partners, data that you don't need to collect yourself, but that you can buy. But for each of that data, you need to ask yourself, do I need it? Will I use it later? Because for Google, it makes sense to collect all data that go through the website, for example, for later use. But for your business, your own businesses, you need to ask if you need to collect to store it, because storing the technology made that really easy to store large amount of data, and it's not that expensive anymore. But we need to ask if we really need that data, or if we need to keep it for a long time. And to reduce the amount of data we keep over time, we can use lifecycle policy that can save a lot of money. We often use lifecycle policies to reduce the bills of the cloud service providers. What I wanted to highlight here is that usually end users are humans that are accessing dashboards. So you need to ask them how often they like the dashboard refreshed. If you are taking your use case from the source, you will ingest lots of data into the data lake and then process it and then store it in its prepared data storage, and then plug the visualization, and your business will tell you, oh wait, I don't need 2 years of data, I need only 2 weeks. So you would have ingested the 2 years for nothing. So if you pay more attention and you do more, you spend more time on business interviews, you will be able to reduce that volume of data, and you will gain from that approach. You will have more. You will reduce the complexity and reduce the processing time, so you will save money. We have many ideation techniques that we use at EPON, because we have a design studio and we work closely with UX guys that are pretty used to do that kind of interviews. So depending on the maturity of the ID, we will use different techniques to make the most of the business need. And most of the time, when you ask your business what you need, it will tell you, I need a dashboard with KPI and so on and so forth. But it's not always the case. Sometimes it would only be an alert in a customer-facing situation. For example, if you have someone by phone at a call center, you only need to have an alert, oh, that customer is interested in that product, and you can tell him, while you have resolved this case, you can tell him that there is a sale on this product. So you will be some upselling, cross-selling, just by having the right information at the right time before, instead of generating huge dashboard that nobody can use because they are too complicated. So ideation techniques are really important for us to reduce the overall complexity of data pipeline and data architecture. We have also, I also use a data innovation board, ideation board that I love, and it breaks your interview in different scenarios, and you can ask the right question and have different axes to work on your use case, and you can share it with all the stakeholders. And I think it's pretty efficient. I recommend you to try this one because we use that a lot when we start a new consulting engagement. You also need to know the data viz option that exists because, as you can see, there are many graphs possible, and this is only a few examples from the 3GS, but you can have a look on their website. They have so many data representations. So sometimes, if you pick the good representation, you won't need that much data because the only thing you display are the aggregates. And sometimes you don't need to keep the raw data, you only need to keep the aggregates and to display it in an efficient way. So now we will see how we can have our servers do less work, but at the right time and more efficiently. The first thing is to not let servers run idly, so trying to use some transient cluster to do the processing, or even better, serverless services, at least fully managed, but ideally serverless services. So to do that, we need to pay attention to always having storage and compute separated, because, for example, on a Hadoop cluster, storage and compute are not separated. So if you need to scale one, you need to scale the other one also. So with modern data architecture, this is a really important thing to keep in mind. And you also need to keep the architecture as simple as possible. Sometimes it's intellectually challenging to design a streaming architecture, but when it's not necessary, it's a loss of time and sometimes money. Because if your human only, if your end user only consume a dashboard once a week, you don't need to be real time. So you will benefit for keeping that a batch process, and everything will be cheaper for you because you will run only one computation per week instead of one for every event. But for some of our customers, try to do everything as a streaming architecture, and it's sometimes counter-effective. You have also many storage options, and using a columnar storage like Apache Parquet is really efficient, and it's a best practice in data architecture to have like a landing zone for your raw data, and then compress it as soon as possible in Parquet, because each following processing will benefit of that compression and that storage format. Because with Parquet, when you query a file, you will access only the column that you need. And when you query a file in CSV, even if you want to read only one field, you will need to read every rows one after the other. And Parquet is much more efficient for that, and you don't need to deserialize it. Parquet can be read in Spark, in Python, in R without deserialization or decompression. And Parquet provides like a 3 to 5 time compression. So there is it's nonsensical not to use compressed storage format, because you will save space, storage space, and you will save processing power. And as I told before, lifecycle policy should be employed everywhere you can, because, for example, you may need to have your 2 last week of data on hot storage, like you aggregate in RAM, but then you can cold it, refresh it, and store on a cheaper storage format. And for example, on AWS, you have S3 Deep Glacier, and it's even cheaper than magnetic tape for archival. So think to your lives. Don't forget to use lifecycle policy to save money on your data storage. Now we will go through a couple of different architectures. For example, the first one is a serverless batch architecture. As I told you before, we use a landing zone to receive the raw data, and as soon as we receive it, we run a glue batch. That is glue is a serverless tool from AWS that enable you to do some ETL processing. And it's serverless. It can run either PySpark code or directly Python code, and it can help you compress and format your data on a Parquet format. So we use it as soon as the data arrives to turn it in a Parquet format, and we delete the raw file that is not compressed and that is not columnar. As soon as we had done that, also I forgot, we also do partitioning. Partitioning is a really important best practice in data architecture, because if you partition, for example, by date, each time you will do a query over your data and you will add a date criteria, you will be able to benefit for that partitioning, because the data won't be browsed through. It won't be loaded. Only the right partition will be loaded. So it's a really important best practice. And after that, you can also use Glue to do your business logic, for example, KPI computation and so on. And then you will store your result in a published data area, like an S3 bucket that we call the working data bucket. And on that bucket, you can plug Athena, that is a querying tool that runs SQL query over S3 stored file. Athena will benefit from Glue because it will connect to Glue catalog. When you crawl file with Glue, you will enrich a data catalog with a schema, basically the schema of your data. And with Athena, you can use that catalog to run your SQL queries without needing to defining new tables and new schema into Athena itself. And we use QuickSight to prototype dashboards and to do some simple dashboards. And since it doesn't read directly Parquet format, we connect Athena. We connect QuickSight to Athena. So that's really efficient, and that way we can prototype data architectures, we can demonstrate capabilities to customer very fast, and then when it needs to scale and to run in production, it's already available, because all these services are serverless services. So it will work as the same way for 100 megabytes to 100 terabytes. That's the power of that serverless. You leave your CSP managing the scalability, and you can have elastic architectures. That's why we don't call it big data, because even if it is small data, it will work the same way. And it's the most optimized regarding the cost and the energy saving, because you only pay what you use with that kind of architecture. The other one is a little variation where we use Snowflake to store the results, because when you want to do some heavy data analytics, you will really be interested in using Snowflake. Snowflake is an interesting data warehouse because it separates the storage and the compute. So once your data is stored into Snowflake, you can have multiple virtual warehouses of different sizes. For example, they use short sizes like XS to 4XL. The biggest one is like 128 cores to process your data workloads. And what I like also with Snowflake is that it automatically suspends the data warehouses when you don't use it. So after 5 minutes, data warehouses are suspended. And as soon as you run another SQL query onto it, it will start again, and you don't pay cold start time. So it's a really good way to optimize your data architecture. Snowpipe is a ingestion tool provided by Snowflake, and it's also serverless. So that's pretty great. The only thing that is not serverless here is Matillion. We love Matillion because it's really simple to develop data flow with Matillion, and it's an ELT, so it needs to load data into Snowflake before processing it, but that means that you don't need to manage a processing architecture, because Matillion will only run on one EC2 server and distribute the SQL queries to the Snowflake DB. And it is Snowflake will take in charge the heavy computation. So you only need to optimize the Snowflake part. Matillion is only UI in some way. So to be cost-wise on that EC2 instance, you only need to start it only when you need, and to stop it as soon as the SQL query has been run onto Snowflake. So we use that architecture quite a lot now to do some various data use cases, such as, for example, temperature monitoring when we have sensors data. We also use that to centralize various kind of data sets, because with Snowflake you can then connect your data visualization, such as, for example, Tableau, MicroStrategy, Qlik, and they will benefit from the analytics power of Snowflake. We also do some heavy computation with Spark. We are very fond of Spark at EPON, and a way to optimize Spark workloads is to use transient cluster. So to achieve that, we use Terraform, which is an infra as code technology, to get the code from GitHub, for example, store it as a zip on S3, and then we pop a transient EMR cluster with the right power, only the power we need, and the right configuration of the Spark cluster. And then the cluster run the code we stored onto S3 and read data from S3 and store the results into another bucket. And we store also the metadata into a DynamoDB database. All that Dynamo and S3 are both serverless services. And IRMA, which is not, is optimized there because it's a transient cluster that we use. And you can also reduce the cost by using spot instances inside your transient cluster. So that's a really powerful approach, and we use it a lot for a customer, and it's really helping to know that your cluster will run only the time you need at the right power, and you can add a power profile, for example, for Q&A or QA environment or production environment. It's really powerful. The last architecture I wanted to present to you is audio analysis. It is a ML AI architecture. We take audio files, for example, a call to a call center from a customer that want to have some information on a product or to place a claim. And we store the audio file into S3. As it arrives, it will trigger a Lambda that will do some transcribe. So it takes the audio files and generate text from it. And then it triggers another Lambda that do the NLP, natural language processing, to extract the relevant information from the text, such as, for example, the product name. And we can use a catalog, a business dictionary, to have more relevant extraction and to do some named entity recognition. And we reach a pretty good ratio of product that were recognized thanks to that business catalog. And it's really powerful. And then we store all that info into another S3 bucket. We crawl the data with Glue to generate a Glue catalog. And then we again plug a QuickSight dashboard onto Athena to display the results. For example, we can display the number of calls of phone calls from different areas. We can display the reason of the phone calls, the product that were concerned, and we developed it in like 2 to 3 weeks to demonstrate that capabilities to customer. So it's really powerful because all the services are ready, and you just need to connect them together with Lambdas to achieve your business case. So we were really happy to see how Comprehend did the named entity recognition with a great efficiency, thanks to the business catalog we provided. So I reached the conclusion, and that is a conclusion about optimization. The cloud is really a good way to attain optimization because the resources are shared between all the customers. So if you have a data center yourself on premises, you will need to design your capabilities to run the peak processing, but the rest of the time many resources won't be used. That's not the case with cloud service provider, because when you don't use any power, they will be able to sell it to anyone else. So it's really optimized. And they work hard to optimize also their network, their energy consumption, and so on. So it's as soon as you use cloud service providers, you already have optimized your architecture in some way. And cloud service provider pay a lot of attention to sustainability. So AWS, for example, is investing a lot in solar farms and wind farms to produce more and more green energy. It's the same for Azure, but GCP on this part is still a leader because it buys a lot of green energy to meet its consumption. And from some of our customers, that is something they want to keep in mind, because if two services are providing the same capabilities, they can differentiate them with that point. So it has already been appreciated by a customer of ours that we, as a recommendation, when we design some architecture, we can orient them to the greenest architecture possible. The serverless is kind of the ultimate optimization, because you don't need to do it. It's your CSP that will try to optimize things. So you will consume only what you use. And this is the core principle of Green IT. Try to not generate processing and storage that you do not need. So it's important for me to have all these things in mind, because now when you will design new data architecture, you will be able to think of it as a data strategy. For some of our customers, they ask us not to use any services on a VM, only fully managed services and serverless services. And that is a good approach, I think, to keep in mind that a good strategy is to reduce cost and reduce energy consumption. That's it for the presentation part. So now I will have your questions, please.
Yeah, I was going to say, and Peter's our new US data practice lead, so he'll jump up as well if you guys have any Q&A on this presentation, on any data practice at all.
I have two questions. The first one, when you showed the architecture, mostly they were starting from the data being in the storage or showing the sources. Like, can you talk a little bit about how you do the ingestion of the data? And also the second one is mostly like on the choice of serving the QuickSight from Athena. And we know Athena, you pay for the query you scan, the data you scan, and like, why did you choose to do that, the structure? Is it because you want to go serverless or something else?
Yeah, so the first one is the ingestion part that is not really covered on this presentation, because usually we try to work that to have that solved at a client level, because they will. It's better if they are responsible of delivering data to your S3 bucket, because as you may know, we have a regulation in Europe that is called GDPR, and with that GDPR, we try to advise our customer to do the anonymization at the source. So they anonymize their data, and then they push it to the S3 bucket. So that's why we didn't cover a lot the ingestion part. As for the Athena usage, we give good best practice to use Athena, and to use always, for example, to define all the column you want to have as a result, and never do select star, because this is already bad practice. And we also try to have some criteria that will reduce the partition that will be loaded by the query. So for certain kind of workloads, Athena works great. For example, for data exploration or rather small dashboarding. But when we need biggest dashboards and biggest computation, we prefer to use data warehouses like Snowflake or Redshift.
Yeah, so just to add to that, I think when you talk about data ingestion standpoint, you could get data from multiple different sources. In fact, you could get it from APIs, you could get it from flat files, SFTP, all these different types of sources. Just to kind of answer your 1 and 2 question, it really depends on the scenario. It's not like a common standard framework that is recommended across the board for ingestion. Sometimes we'll add in Kafka or Kinesis here when we have real-time streams and real-time data sources. So as a generic answer, it's hard to answer that. In terms of the second question, when you're using Athena and QuickSight, this is only an example of a reference architecture that could be applied. In fact, in many different clients and many different organizations, we went from using Snowflake and using even Tableau with Snowflake. We used Redshift. We used Tableau with Redshift or any other sort of BI tool. We built custom things using JHipster and connecting to a number of different warehouses. We wanted to highlight the serverless aspect, especially in this reference architecture. And Athena and the partitioning and the compression are very, very key points when you're kind of putting this all three together. So hope that answers your question. Okay.
Yeah, but because we are recording this live, so we want all the questions.
So when you are importing the data, right, like the first time, so and then you start to filter out what data you want to keep and what data you want to throw. So how do you decide which data you want to keep? Is it all based on business sense, or do some pre-processing of the data, analyze the mean, medium, and all the stuff, and then realize that some columns might not be worth it to carry on to the further processing of the data? And I mean, what's the whole process?
It's during the interview phase when you interview your business, you will be able to understand what data are needed, and you will try to store only the data that are needed. So this is why I was stressing out the ideation techniques, and business interviews is a critical phase to have an optimized data architecture. So you will store the needed data, of course, but your business will explain you what historical data are needed for how long you need to keep your data, and then you can develop life cycle policy to delete the data you don't need anymore.
So you guys use the ideation process to decide which data to keep, right? And that's done with the client, right? And what if in case the client is not an expert and he does not know what kind of data he needs, right? So you guys have to guide them, based on your experience, like you should keep this data and you should not, right? And I'm not sure if you guys are perfect every time, but I think everyone makes mistakes, right? So in that case, you go back to the client and say that, we considered this data before and we found out that it's not much used and we are removing it now. Or maybe in case the client wants to keep that data in the whole process and you realize that data is not needed, but clients really want it, then in that case, what do you guys do?
So I'll take a stab at this too. So Arnaud also mentioned that this is a continuous ideation process. So I'm not sure how many business folks are here today, but I've gone into so many meetings where they actually don't know what they want, right? And they're like, "What do we want?" And we need to build them or show them the good direction, right? Or give them a taste of what tastes good, right? So a lot of times it's a back and forth kind of cyclic process to define what good looks like. So I've also noticed that, we talked about kind of archiving and getting rid of the data that we don't need. And a lot of times these scenarios where there are these gray areas, we're not exactly sure how we're going to use it. We work in conjunction with not just the business users, even data scientists who try to create insights. Our infrastructure team to come up with the best retention policies, but we also offload things to cheaper storage. Arnaud talked about Glacier, where it's fractions of a penny per gigabyte, right? So we want to make sure that we leverage all these different aspects, and if we need it, we still have it.
Yes, you maybe won't need to keep it in a hot storage area, such as a query engine or a data warehouse, but you always keep it on S3. And if you realize you need that data back, you will re-ingest it.
You mentioned about using Spot instances for a transient cluster, EMR transient cluster, but do you recommend that for a master node? I understand for core and task, but do you recommend Spot instance for a master node in EMR cluster?
In fact, we did a lot of testing to find the right configuration, and we even developed a framework for that to configure our cluster depending on the need. So that is the complicated part with Spark, is to have the right configuration according to your needs, and that's with experience that we are able to define that. There is no easy answer to that. You need to test and learn, to test various cluster configuration, various memory configuration to reach the sweet spot in terms of performance.
I think the major question is, if your master node goes down, you're done, right? So that's primarily the reason. So I've seen different ways people attack it, where they give a certain spot price for and then their master node is like 3 times the cost, right? So they were like ensure that the master node won't go down. So I've seen different things, but I think there's a different way to handle this and to cater to your need. I don't think there's a generic answer, so it's hard. It's a very hard question to answer. So.
And in the worst case scenario, if your master node is done, if you have a problem with your cluster, you don't mind because it's a transient cluster. So you shut down it, you relaunch your processing, and it will run well the second time. So it's not like a long-running cluster that you need to manage and to keep running smoothly. This cluster are dispendable since they are transient, so you just need to shut down it and to recreate it. It's since it's infra as code, it's only a script to launch to have everything running.
Comment on that. The case I've seen is where like you still have the data, you can just retry the workflow for
Yeah.
Yeah.
The question is on the architecture, which we saw. In most of the architecture, you are using QuickSight. So as I know, in QuickSight, you cannot share your dashboard with someone who is not part of that particular account. In most of the cases, only developers will have access to the account. And for example, if I have to share the same dashboard with someone who is not part of the account, for example, my manager or the customer, definitely they will not be able to access the dashboard. So what is the benefit of using QuickSight? So in that case, we can use something like Kibana or other dashboards.
You can share QuickSight dashboard if you use the enterprise version of QuickSight. You can share with people that do not even have an AWS account. But we use QuickSight a lot for prototyping, and when you need to produce report to share group-wide or to produce reports for VIPs, we use a bit more advanced dashboarding tools such as Tableau, MicroStrat, and so on.
And just to add to that, I think each BI tool, and we could go into each of the BI tools, but they each have their pros and cons. Kibana also has their list of pros and cons. I think it all depends on your individual reporting requirements. What we noticed was because it's an Amazon ecosystem, that when you have access to QuickSight, and you've used some of these technologies that we're talking about, like Glue and the Glue catalog, it's very, very quick to kind of dashboard things in QuickSight. So, we could actually substitute that with other reporting tools and other BI tools, but this is just kind of one of the ways that you could really kind of quickly get some dashboards using QuickSight.
So I have used QuickSight, but not enterprise versions or not.
It has its pluses and cons. I mean, pros and cons. So there are a few things. What I noticed from a developer standpoint as well, it's very easy to get some quick insights to show a variety of different folks. So.
One more question on the architecture. It's a OLS architecture where the transient EMR cluster. So you mentioned about using Terraform. So where does that Terraform run? Is it through Lambda function, or is it on a EC2 instance?
Which tool?
Terraform to spin up the transient.
Terraform. Oh, okay. Good question. No, the Terraform run onto AWS as well, and it runs on EC2 instances, I think. I'm not sure of that part because the DevOps guy is in another team, but we built a framework thanks to that, and we have like more than 1,000 lines of Terraform code to deal with every possible aspect of our architecture.
I mean, I could add to that. I mean, when we're using it, we usually kind of kick it off through like a Jenkins script or something like that. We kick off the Terraform. It actually builds the transient cluster based on your configuration. So there's 1,000 lines Terraform script. I mean, if you want to get started really easy, you could just look at it. There's a lot of tutorials on it online as well, but you could quickly create your cluster the way that you want it with the spot price, the bid price and everything. So it has a lot of different ways to build these transient clusters in the way that you want it, and that's why we put it in there.
My question is the file format you suggested for the Parquet file format. So is it a good format to use, let's say you have a landing area and working in Power. So do you recommend using in all these layers, or like for example landing area, we most likely use all the columns. After we land the file or data, you usually read most of the columns and then go to working and then go to publish. Only publish will be a limited number of columns. So if you have a Parquet file format, if you read all the columns, performance-wise will it be beneficial, or should we consider the other formats like row or any other formats where it's a row format like row storage?
If you read, so is Packetful good if you need all the column? Yes, but only because of the compression. The packet compression is 3 to 5. JZip is 9. So you would prefer to use JZip instead of Parquet if you load all the column. And for example, with Snowflake, you can directly load JZip into tables. You don't need to do the decompression yourself because Snowflake will do it for you.
The same question. Parquet doesn't support splitting, right? So is it a good idea to use Parquet? It doesn't support splitting of data. If I'm reading Parquet from Spark, Parquet format doesn't support data split.
Data streaming?
Data split. While reading, it doesn't read parallel, right?
Yeah. So.
It doesn't support splitting of data.
Okay.
I think the main point that we're trying to stress here is to be able to, because I know there's ORC, there's Avro, there's Parquet. I mean, we could kind of go through, and there's probably a million different articles online to say which one and which format meets your best use case. It's like kind of saying, okay, depending on which one, like which database is best for you, or which storage or which cloud provider is best for you. Again, there's different ways to tackle the problem. You know, in this case, I'll probably use Avro, right? It really depends. But the one thing that I've seen in I guess in my experience is Parquet is being heavily utilized across the industry, across data. In fact, even there's new connectors that are coming out with Amazon, especially like with Redshift, right? Unloads are awesome, right? If you guys ever use it, they're actually going to be unloading to Parquet very soon, if not already, right? So, you know, this allows you, when you're reading things using Athena or even everything else, it takes up less disk space, it's more compressed, and it's in that columnar format, so you could really scan the data very quickly. We're not saying that Parquet is the absolute compression method that you should use and the file format, because again, ORC, Avro, and other formats are out there.
And sometimes in some use cases, we even use the data rows to run the computation. And once it's done, we unload data to Parquet on S3 for later use for the data scientists. Thank you, everyone.
One thing I actually do want to mention as well is we do have a couple copies of this book that was written by one of our data experts on Kafka. Obviously very relevant to today's technology world. Streaming is the big thing. So if you guys are interested in this topic, like I said, I do have about 7 or 8 copies on hand. But again, thank you to both of you, especially for that Q&A. Like I said, so we're wrapping up now. I think there's still a lot of food left, so if you want to grab something on the way out, please do so. Otherwise, it's going in the receptacles. So thanks once again. Like I said, look out for our name. We will definitely be doing this again. Thanks for braving DC area traffic. I know it is never friendly when it gets warmer especially. So have a great night, and we'll see you all next time. Oh, actually, Naveen's here.
I think you might know I run big data analytics and artificial intelligence meetup group, and we are around 2,500 people in the DC area, and what we are trying to do is the company like Epon and a speaker like Arnaud, and bringing technology, company, and people together to learn more. And I wish I would be here earlier, but today I have to attend a DataWorks Summit, which is run by Cloudera. And I come to know that Cloudera and Hortonworks are merging together. So now they are the only player in field of big data. So there are a lot of things which we wanted to bring. What I learned, we will be sharing in few upcoming meetup sessions. So I want to thank you, Epon and Arnaud. I think you are Nicholas. And you guys to show up in DC traffic and attend be part of our meetup group. Thank you, guys.